Welcome, ladies and gentlemen. Today we're going to talk about exponential growth and decay, real life examples. This stuff, if you want to know how your math is going to apply to you, this is huge, all right? So make sure you have your guided notes out. You really want those because there's lots of writing. If you don't have them, a pen and a pencil and a calculator. All right, here we go. First, you guys have this printed out. We're just going to fill in a couple of things, okay? Compounded interest is an example of exponential growth. We use this model when we are not compounding yearly, okay? So here's our equation. A equals P times the quantity 1 plus R over N, all to the N times T power. So P is our initial amount deposited. R is our interest rate, which we have to express as a decimal, not as a percent. Okay, that's very important. N is the number of times compounded per year. So this is what you guys need to fill in for me. Semi-annually means it's going to be twice a year. Quarterly means 4 times a year. Monthly means it's going to be 12 times a year. Weekly, we're going to put 52 weeks in a year. And daily, we're going to use 365, okay? And T is the number of years. A is the balance after T number of years, okay? Now we're going to move on to our first example. Here we go. If we're going to do compound interest, if we deposit $2,900 in an account that has a 3.5% annual interest, we need to find the balance after 2 years if the interest is compounded monthly and weekly. So we're going to do 2 of these. First one we're going to worry about is monthly, okay? So we're going to go through and fill in what we know. P is our initial amount, so that's $2,900. R is our interest rate, which is 3.5%, but we need that just as a decimal, so that's going to be 0.035. Now when we get that, you guys can just divide by 100, okay? N is the number of times compounded yearly. So in this case, we're going to use monthly, so we're going to put 12 in here. The time it's going to be in is 2 years. And A is what our balance is going to be after those 2 years, so that's what we're trying to find. So now we're going to plug it in to our equation. So we have A equals 2,900 times the quantity 1 plus 0.035 all over 12, and this is all to the power of 12 times 2. Now we're just going to simplify a few things here. So A equals 2,900 times the quantity 1 plus, when we divide this, we're going to get 0.0029, and then we're going to take it to, it'll be the 24th power. Now we're just going to simplify again, so I have A equals 2,900, 1.0029, 24th. Now once we get here, we want to type this into our calculator as is, okay? So we're going to type this into our calculator, and we're going to figure out that our amount at the end is going to be $3,108.72. Okay, so that's if we do it monthly. That's how much we're going to make. Now, if we had it compounded weekly, we're going to do that one now. So same example we're on, except for now, ladies and gentlemen, we're working with weekly. So our N is going to be 52. So everything else is the same. Only thing we're going to change is how often we're compounding it. So we plug this in, we're going to get A equals 29,001 plus 0.035 all over 52 now. And in our exponent, we're going to have 52 times 2. Simplify this. A equals 2,900. 1 plus 0.00067, all to the 104th power. Now we're just going to simplify this one more time. So A equals 2,900 plus 1.00067 to the 104th power. From here, this is where I wanted you to just plug it in your calculator. So we're going to take this times this to that power. So A should equal 3,109 and 21 cents. Okay, so this is how we're going to find out how much money we can make when we're compounding something. Okay, our interest, compounding interest. All right, now we're moving on to the next page of your notes. You should have exponential growth model. So real life, so y equals a times the quantity 1 plus r, all to the t power. Okay, where a, make sure you guys write this down for me right here. A is the initial amount. R is the percent expressed as a decimal. And t is time. Okay, now this is really important. You might want to put a star right next to this. The 1 plus r is our growth factor. Okay, since we're taking 1 plus our rate, it's going to be a growth. Now we're going to do one example with this. So let's look at that example. There was an initial population of 38 buffalo in the state park. The population is growing, so that's why we're going to use our growth with 7% each decade. Now I'm going to stop you right here because it's important to know what decade means. Decade means 10 years. Okay? Write an exponential growth model and estimate how many buffalo are in the state park after 70 years. So if we have this, we have to figure out what our A, and our R, and our T are. So A, we're starting with 38. Our rate is 7%, but as a decimal, it's 0.07. And our time, now this is tricky here, because it says 70 years, but it's every decade. So we have to take 70 divided by 10, which is just 7. Okay? From here, we're just going to plug it into our formula. So our formula is y equals a 1 plus r to the t. So y equals 38 times the quantity 1 plus 0.07 and to the 7th power. Simplify this. Y equals 38 times 1.07 to the 7th power. Type all of this into our calculator and we get y equals 61.02. But now since we're talking about buffalo, we can't have 0.02 of a buffalo. So our answer is just going to be 61 buffalo. So our population is going to increase by 61 buffaloes. All right, moving on to exponential decay model. So this is going to look very, very similar to the exponential growth, except for now we have y equals a times the quantity 1 minus r to the t power, where a, make sure we write this down, a is our initial amount, r is our percent decrease expressed in decimal form, and t is our time. Now, just like we mentioned before, this right here is important because it says 1 minus r. Since we're subtracting, it's going to be a decay factor. All right, let's move on to our last example for today. So, this is a huge deal to me, you guys. So huge. One thing I'm going to say right now, never buy a new car. I'm going to keep repeating myself. It's not a wise decision, and you'll see when we go through this. A new car costs $25,000. Okay. The value of the car decreases by 23.5% each year. So decreases. We're losing money. We need to write an exponential decay model, and we're going to get the value of years after 4 years. So our A equals our initial amount, which is $25,000. Our rate is 23.5%. which is 0.235 as a decimal. That's what we're going to use. And our time is going to be after 4 years. So if we write it in our equation, y equals a times 1 minus r to the t power, y equals $25,000 minus 1 1 minus 0.235, whoops, to the fourth power. Now, y equals 25,000 times, now we're subtracting, so we get 0.765 to the fourth power. We're going to type this into our calculator, and y is going to equal a dollar amount of 8,562.20. So after 4 years, which you might not even have it paid off by then if you took out a loan, your car is only going to be worth $8,562.20. Look at how much money you are losing. Okay, so my word of advice for today is never buy a new car unless you're going to pay cash for it, because you are losing so much money. Okay, with that being said, I hope that you guys have a wonderful, fabulous rest of your day, and I will be seeing you soon. Bye.